For this lab, we will be looking at how to implement a simple undo and redo functionality in our text editor. To do that, we'll be using a new data structure called a stack. As you know, most word processing applications that you use have pretty dynamic undo and redo functionality. In C#, the text box control does actually have some undo functionality if you press Ctrl Z, but it will only undo your last edit and will not go past that. In order to do undo or redo, we need to be able to keep track of all of the edits made to the text, as well as the order in which they actually happen. To do so, we will make use of a stack, which keeps track of all of its elements in last in, first out order, or LIFO. A stack is nothing more than a sequence of elements, much like an array that has been stood up vertically instead of horizontally. An array, you can access, modify, and delete elements in any order you choose, but in a stack, elements are stored in LIFO order, so only the last element or top element can be accessed at any time. Some implementations actually have ways to get around this aspect, but that really kind of defeats the purpose of what a stack actually is. So if you find yourself needing to access any arbitrary elements, or elements in a different order other than LIFO, then a stack is probably not the correct data structure for you to use for that application. But let's take a look at an example of some of the operations that we might use for a stack. But for these to work, we need to always know where the top of the stack is. Note that in this image, the bottom of the stack down here is the bottom square. But if the stack is empty, that is also where the top of the stack is too. But the three primary operations of a standard stack are push, pop, and peek. Push simply adds an element to the top of the stack. Pop will remove an element from the top of the stack, as well as returning the value that was actually removed. Peek will simply look at the top of the stack, return that value, but not remove it. Let's take a look at how these operations work on the stack. So first off, let's push cat to our stack. Now when I push, I'm adding that element to the top of the stack where the top actually is at, where the top pointer is. Next, let's push dog. Now you notice when I push dog, the top of the stack actually moves. So when I'm pushing, I'm always adding the element to the next available position in the stack, and top will move to indicate where that position actually ends up being. Today's lab, we're actually going to be able to push mixed data types to our stack, so I don't actually have to push all strings in this example. I can push numbers, and I can push really pretty much any other object that I really wanted. When I peek, it will simply return the top value on the stack without removing it. Now if I push again, push 2 onto the stack, top moves all the way to the top, moves up again, and if I push another element onto the stack, I can still go. Even though I have no more open spots on my stack, the stack data structure will grow with the number of elements that I try to push on. In future labs, we'll learn actually how to implement our own stack and have to actually grow our underlying data structure so in order to make room for those new elements. Now, when I remove elements from my stack, I want to use pop. Now, pop takes no parameters, but when I pop, it removes the last element on top of the stack, or removes the element on the top of the stack and returns that value. For lab today, we will use the C# library system.collections.stack. This implementation will allow you to create a stack of objects. Since all data in C# are objects, that means the elements on top of the stack could literally be anything, as we saw in our example before. But while that makes pushing elements to the stack pretty easy, it's a little tricky when you're working with it because the type of the item on the stack cannot be inferred past the being a plain simple object at compile time. So a string on the stack can only be inferred as an object, not a string, when the program is compiled. This means that when you use this class, you will have to convert the data to the type you need when popping or peeking from the stack. This class contains a read-only property called count. This will keep track of the number of things on your stack at any point in time. This is very useful because you can't pop a stack that has no elements on it or peek. Some operators actually, like as I said, some operators are only valid when the stack contains at least one element. So if you try to pop an empty stack, you're going to get an exception. For other labs, we will look into generic stacks, which will let us create stacks, among other things, that contain more strongly typed data. So for example, we could have a stack of strings or a stack of ints. Important method signatures and usages for the stack class can be seen here. As I went through my example, we have our push, pop, and peek operators or operations. Each one of these methods are listed here accordingly, but the only one that actually has a parameter is the push operator or the push method. Now, make note of the data type here. It's pushing a generic object. So again, all data types in C# are objects, so you can push anything onto your stack here. I also have corresponding usages here. So for example, pop and peek. Let's say when I pop, I'm expecting an integer, but when you actually pop, it returns a generic object or a general object. So you actually have to convert that object to the expected data type. You can do this in most cases by just using a cast. So in parentheses before the actual return or the actual object that you're trying to convert, just put the data type in parentheses and it will cast that object to that particular type. But just keep in mind, if you don't actually know what data type you're popping off or peeking, you can actually run into an exception because you can't convert dog, which is a string, into an integer or a double, for example. But this is pretty much it for the lab today. You are primarily focusing on making your undo and redo functionality using this stack class.